Hello and welcome to this talk about our exploratory study of hardware reverse engineering. My name is Steffen Becker and this is joint work with my colleagues Carina Wiesen and Nils Albartus, as well as with our supervisors Nikol, Rummel and Christof Paar. Let's talk about hardware reverse engineering, HRE. So when designing a microchip, you typically start with a high level of description and then there's a lot of engineering involved. Those microchips are then getting placed on PCBs, which you find in almost all electronic devices, such as smartphones, airplanes, or critical infrastructure devices. You can also go the same way back. You can disassemble those devices, get out the PCB and the chip, and then when you analyze the chip in order to understand its inner functionalities, this is called hardware reverse engineering. And HRE has a lot of legitimate and illegitimate applications, for example, in the areas of IP infringements or hardware trojans. So how does it actually look like when you analyze those internals? It's called a netlist, which consists of thousands up to millions of different components, which you have to make sense of. Then there's this model for netlist reverse engineering, which consists of semi-automated processing methods on the one hand, which are steered by the cognitive processes of the reverse engineer on the other hand. And those cognitive processes are so far under research and poorly understood, which opens the research gap for our work here. So in our paper, we formulated 4 research questions, which I'm going to introduce briefly here. So we looked for phases of human sense making during HRE. We also wanted to know more about more and less efficient strategies reverse engineers applied. We are interested in the cognitive prerequisites which influence the success of HRE, and we wanted to apply our findings for cognitive obfuscation in the future. So due to the shortness of this talk, I'm only going to address ARQ1 and ARQ3 briefly. Underlying was the exploratory study, where we recruited 22 bachelor's and master's level students who went through a 14-week HRE training where they acquired relevant HRE skills and knowledge before they solved an HRE study task over the course of 2 weeks. We then selected the 8 top-performing participants and were also able to recruit 1 validation expert with 5 years of experience in HRE who also solved our task. So let's come to the results. We could indeed identify 3 subsequent phases of sense-making in HRE. So first, our participants identified relevant components before they verified that they indeed found the right netlist components. And then in the third step, they realized their goal, which was in this case to remove an IP protection mechanism. So here we can see the progress of all our participants who spent most time in the second phase, in the candidate verification phase, as we can see in this figure. Another interesting finding regarding ARQ3 is that participants with a higher working memory score tended to solve the assignment more quickly. But as a disclaimer, this is only a descriptive analysis. We didn't calculate anything due to the low number of participants, so we need further research in the future, and this can only serve as a first indication. So let's come to the future work, to cognitive obfuscation. If this is an unobfuscated netlist, then we want the obfuscated netlist to look like this. And how do we do this? How do we then overload the capacity of the reverse engineer's working memory? Well, we're going to do this by employing, for example, dummy wires or camouflaged gates, which are physical obfuscation primitives from the literature. So let me quickly wrap up. So our work is the first step towards a better understanding of cognitive processes in HRE. We found a 3-phase model. We also found that our participants combined manual and semi-automated analysis methods, and that the cognitive factor working memory might influence hardware reverse engineering. Of course, our work comes with a number of limitations. First and foremost, a small sample size of students, and that we had only 1 expert. And also, we cannot generalize our findings to all HRE problems at the moment. So in future work, we want to actually develop cognitive obfuscation, and we want to further quantify the cognitive influences of HRE. Thank you for your attention, and Carina and I are looking forward to your questions here online now or later offline. Thanks a lot.